Hello everyone, this video is going to discuss one method of doing gas analysis for combustion systems. So what we have is a combustion chamber with the exhaust gas coming up through this hood and then sample gas being collected in this sampling tube, which actually comes in and turns into does a J-turn to point back towards the sampling, which isn't the best for being if it gets clogged, but it's the way it's set up right now. So that sampling gas comes out of this connection here, runs down, and then is going to go through a sequence of filters and conditionings. So this is a heat exchanger. It's actually the cooling unit out of a college dorm room size refrigerator, so it works relatively well. We then have a filter unit here with a collection for water. So when you have the cooling of the combustion products done by the heatsink, the water will condense out on these copper tubes and drain into the filter catch here. It's also a HEPA filter, or I forget how many micron filters it is, but it collects very small particles, and since we're doing some dust combustion in this work, it's good to remove the particles. Once it goes through the half of the heatsink, through the filter, up through the second half, it goes through a Ballston acid filter, so that collects any excess acidic vapors that have come through the combustion process, or generated by the combustion process, I should say. Then we come up and go through a desiccant. So we have dry right. This is a commercial dry right filter. I built one. I built two, but I put too much pressure through it, and the first one kind of blew apart. So I decided this is worth buying commercially. Then we come down through here and we go through a pump. So we have a pump that's pushing, I forget how much the volume of air it pushes, but it's enough. It's more than 1/4 liter per minute, which is what we need. It's actually significantly more. So the gas comes out of the pump, goes into a separator, which isn't actually necessary, but it came in the system, so I left it in there anyway. And then we have the line splits. So this one goes to a flow meter or rotometer, and so when it's running, we're going to sample at 1/4 liter a minute. So you have to set this each time so that you're getting the right amount of flow. You want 250 cc's per minute, so you want the volume to be right about here. I'll turn this off because it's loud. And the excess is vented back into the hood. So this line goes back into the hood return. And the reason you do that is because if you don't vent the excess, you get a pressure buildup in the line, and then it takes forever for the sensor to respond. So once our gas goes through this flow meter, it's going to go through a servomix analyzer. So the servomix analyzer is here. We can measure oxygen, CO, and CO2. Currently we're only measuring oxygen. Oxygen goes in through the sensor and then comes back out and into the hood return, so that we don't just vent it into the lab. Also, there's another, I believe it's a 0.5 micron filter here to capture any particles that either came out of the desiccant or the pump. So the pump is an electric motor, and sometimes they put off graphite or some other type of carbon dust. So we don't want that to go into our sensor unit. So then we're collecting the data from the servomix unit through, we have a RS-232 cable, and then that is going through to a USB adapter, and that is being collected on a hyperterminal on the computer. So we have the standard hyperterminal. This is actually Windows 7, so if you're using Windows 7 or something above, you have to get the hyperterminal software from an XP computer and install it on your computer that you want to use. But once you do that, it does seem to work fine, and we're sampling at 1 hertz. So when we set up the servomix analyzer here, we want to set it to a continuous output with, it's 9600, the baud rate is 9600, and there's no polarity. But whatever you set this unit to, you want to set your hyperterminal to be the same thing. So I hope you found this video useful, and have a good day.